Hey all, welcome to homeschool. Hope everybody are doing good. And I am back with class 11 physics series, and I am with the most requested chapter of class 11, that is motion in straight line. So today we will discuss few aspects of motion in straight line. See, this is the most important chapter of class 11. You should definitely concentrate for board point of view as well as for competitive point of view. Okay, so let me give a complete concept clarity on all major concepts of motion in straight line. So we all know the meaning of the word motion, right? So what do you mean by motion here? Motion is a movement, right? It is a change in position with time. It's called motion. Say I am standing here and I move. Say my position is changed. I was there, now I am here. And this change in position took place with respect to time. Yes or no? So I was here, I moved here in some fraction of time. So this movement of an object with respect to time is called motion. Okay, so what is motion here? Change in position of an object with time is called motion, right? Fine. And this chapter is all about rectilinear motion. Okay, so what do you mean by the word rectilinear motion? Rectilinear motion in the sense motion in straight line. Motion in straight line. Or we can also say motion in one dimension. Okay, so such a motion is called rectilinear motion. Say I am here and I move only in one dimension, right? So motion in straight line. This is an object. If this is moving like this, or if this is moving like this, or if this is moving like this, say how is this object moving? It is moving in a straight line. So motion in straight line or motion in only one dimension is also called with the name rectilinear motion. Okay, so this is the physics term, rectilinear motion. Fine. So we got to know what is this motion, right? Say here, this chapter is all about various terms that describes motion. Okay, say motion can be described, motion can be explained with the help of lots of terms like distance, displacement, okay, displacement, distance, the difference is very important and I will give that difference today in this class. And then it can be described with the help of a factor called speed, and there is another factor called velocity, and there is one more important factor, acceleration. Okay, so mainly motion in a straight line or motion in any direction for that matter can be described with the help of these terms. So the entire chapter is about understanding these terms, okay, and calculations involving these terms, right? So hope you got cleared with the concept what we are actually studying in a chapter. Fine. In today's video, I am giving an entire explanation or description about the distance, displacement. Then we have something called speed, average speed. Then we will go for average velocity and numericals related to these concepts. Okay, so this is all about today's class. See guys, now understand the concept very clearly that there is lots of difference between distance and displacement. Okay, say for example you have a ball here, right? And a ball from here, it is moving here. right? So this is the initial position of a ball. Usually, you know what, position is denoted with the letter X here. Okay, so whenever I write X, it means that position, right? Okay, so this is initial position of a ball. Say, let me write it as Xi, and this is final position of a ball. Let me consider as XF. Okay, and how can a ball come from this initial position to final position? It may take various routes. It may take various paths, isn't it? Say from here, the ball may take this path and can come here, or the ball may take this path and can come to this position, right? And there are several ways or several paths that a ball can take to come from initial position to final position, right? And this is what, this path length, which we call it as distance. Okay, so what is this? This is path length, length of a path length. Okay, what do you mean by this? Length of a path is called path length, which is nothing but we can call it as distance. Okay, so this is the path length or distance 1, and this is the other path length, and you know, this is also a distance 2. Okay, so this is first path and this is the second path, and this much is the length of the first path. So that length of a path, which we call it as distance. Okay, so this is one distance, this is another distance, right? And now what is displacement? Displacement is this distance. Okay, displacement is what? Change in position is called displacement. Okay, so how do you mention change in position? Change in position, how do you represent? That means change anything, you know, mathematically or in physics and chemistry, we represent with this delta. Delta means what? Change in what? Change in position, that is delta x, which is equal to final minus initial, right? So final position minus initial position. Okay, so this is how we normally calculate displacement, and this change in position, which we will call it as displacement. This is what we mean by displacement. Okay, so hope you are clear with the difference between distance and displacement. Distance is what? Path by an object that it has traveled. Okay, so it is that path length which we will call it as distance. Whereas this one, okay, change in position. Initially ball was here and finally ball is here. And this distance, okay, this change in position is what we mean by displacement. Okay, so in the name itself we have place means what? Here place has changed. Okay, say initially it was here, finally it is there. Place is changed. So that distance, that change in position, we will call it as displacement. Okay, fine. And let us understand this with one more example. Suppose you have a ball, okay, or there's a person who is moving 8 meters this way. Okay, and again this person is moving 2 meters this way, right? And finally the person arrived here. Person initially moved 8 meters in a forward direction. Again from there he moved 2 meters in a straight line. Okay, and this is initial position of a person and this is final position of a person. Can you tell me how much is the distance? How much is the distance he has traveled? Initially person was here, he moved 8 meters and then from there he moved again 2 meters in a straight line. Okay, so the total distance, I can say here, total distance is equal to 8 meters plus 2 meters. That is equal to 10 meters. So the distance is a path length okay, in which a person has moved from this point to this point. So total distance he moved was, 10 meters. But what about the displacement in this case? Person was here and final position of a person is this, right? So displacement, how do you calculate displacement? Displacement, right, which we can call it as delta x, is equal to final position of a person xf minus xi, right? The person is standing after 10 meters, right? So 10 meters minus, initially it was a 0 meter, so 0 meter. So here also 10 minus 0, 10 meters. So displacement is also 10 meters, distance is also 10 meters. So in this case, distance was equal to the displacement. Does every time our distance is equal to displacement? No. Okay, you observe this example. Observe carefully. See, you have a car, right? And it is moving 2 meters this way. And from here the car is moving 4 meters this way. And it took a U-turn and it has come back, 2 meters backward, right? 2 meters backward. So in this case, can you calculate how much is the distance and displacement? Right? You observe the question here. This is question 2 or example 2. Car moved 2 meters this way. Again from here 4 meters forward. And later it took a U-turn and it is moving backwards. That is 2 meter back. So how much is the distance here? The distance, the total path, 2 meters plus 4 meters plus 2 meters. Okay, I'm worried about the total path. Okay, I'm not worried about the direction or whatever it is, right? So just the total path, the total distance the car traveled altogether is 2 plus 4 plus 2, that is 8 meters. So this is your distance. But what about displacement? What about displacement? Right? Observe carefully. 2 meters plus 4 meters. Yes, so this much. Okay. Minus, the car is moving backwards. Right? So minus 2 meters. Minus 2 meters. So how much is your displacement? 6 meters minus 2 meters, that is equal to 4 meters. You see, the displacement is 4 meters and distance is 8 meters. So every time displacement is not equal to the distance. Actually, the distance is always equal to or greater than displacement. Okay, so this point is very, very important. Take it as a note, guys. Distance, your distance is always either equal to or greater than displacement. Greater than displacement. So this is really very, very important. And one more point I would like to mention here. Distance is scalar. Distance is scalar quantity. Okay, whereas displacement is vector quantity. Displacement is vector quantity. Okay, so what do you mean by scalar quantity? A quantity which has only magnitude. We don't bother about direction here. Okay, see distance. Distance, you see, we only consider the magnitude. I mean the total path that a car has covered, right? So that is the amount. Magnitude means what? Amount or the total path that a car is covering. We don't worry about the direction, right? So distance is a scalar quantity. Whereas displacement, when you come to displacement, direction also matters a lot. See, the car was here, it came here, again it took U-turn and now the position of a car is this. So this much is your displacement, right? Hope you are getting my point. What is the displacement? Displacement is final position minus initial position, right? Initially the car was here, but finally after it took U-turn and came here, and this is where the position of a car. So definitely you will not have a displacement 2 plus 4 plus 2. right? So you will have a displacement 2 meter plus 4 meter minus this much you should take it off, right? So that is how we will calculate displacement. Okay, so direction is also very important. We consider direction for the displacement. So the quantity which has both magnitude and direction is called vector quantity. So this is the most important basic idea one must have. Distance is always a scalar quantity, whereas displacement is a vector quantity. Okay, and you know what, displacement, when you calculate, you can either get a positive value or negative value. Say here, every case displacement I had value in positive sign, right? But you will also have displacement in a negative sign. Okay, so this sign actually tells you about the direction. Okay, this sign actually tells you about the direction. Just try to understand this example that I'm showing on a board. You see guys, I have a x-axis where this is a 0. This is a point of reference. Say always any object when it is moving, it should start from a particular point, right? So that point we will call it as reference, point of reference. Okay, fine. And you know what? Okay, so this is 1 meter, 2 meter, 3 meter, 4 meter, and so on. Fine. And you know, I am actually here. Okay, so I am here. And I moved backwards. Okay, and I moved, and I came here. I came here. So this is my final position. Okay, and this is my initial position. And can you calculate how much is the displacement here? You see the displacement. I am calculating displacement. So how do you calculate displacement? X final minus x initial. Okay, final position minus initial position. Which is my final position? It's here. That is 0.5 meters. Okay, so my final position is 0.5 meters minus initial position is around 2.5 meters, isn't it? I am exactly in between 2 and 3, right? So 2.5. So what is the value I got? I got around minus 2.0 meters. You see, the displacement is equal to minus 2.0. So displacement can also be a negative value. Okay, so this negative actually tells you that the direction in which you are moving. Okay, so this sign will give you an idea about in which direction you are actually moving. So displacement is a vector quantity. You need to consider the direction also. But in this chapter, we don't discuss too much about direction. Okay, so we don't need to worry about this sign. Okay, so we only consider the magnitude of displacement. Okay, so here the magnitude of displacement, the mode of displacement, mode means what? It can be a negative or positive. Just the number is important for us, right? So magnitude of displacement is equal to 2.0 meters, we say. Okay, so just to make you understand that we will get a negative value for displacement, I gave you this example. Say this negative or positive sign will actually give you an idea about in which direction the object is moving. Okay, but as far as this chapter concerned, we can neglect these signs and we only consider the magnitude of displacement. Okay, just the number, the digit we consider here. Right? So this is all about the displacement and distance. So this differentiation is very, very important to understand, guys. And now I will go for speed and velocity. Speed and velocity. Okay, actually we discuss average speed and average velocity. I'll tell you what is the difference between average speed and speed. Okay, just a normal speed or uniform speed. Okay, so usually speed is nothing but distance by time. Okay, velocity is nothing but displacement by time. displacement divided by time. You can observe the difference between speed and velocity. Both are not same. Okay, so speed can be calculated by this formula. It is distance. You know the distance is path length. It's a scalar quantity, right? So distance by time is your speed, and displacement is a vector quantity, right? So displacement by time is our velocity. Okay, and usually when an object is moving in a straight line in a same direction with constant speed, okay, if it is moving in a straight line with constant speed, right, without changing any variation in a speed, if it is moving in a straight line in a same direction, such velocity we will call it as uniform velocity. Uniform velocity. Okay, so if the speed is uniform, constant, okay, say for example a car is moving in a straight road with same speed, then such a speed we will call it as uniform speed, or if you want to talk about velocity, you will call it as uniform velocity. But practically speaking, you know what, we don't observe uniform velocity. See, when a car is moving on a certain road, we increase the speed to some extent, and then again we decrease the speed, right? So if a car is moving on a road, right, initially if there is no disturbance on a road, it moves faster, right? And again if there is a disturbance on a road, it becomes little slow, right? So you know what, uniform speed or uniform velocity is practically not possible, right? So you have ups and downs in the speed or velocity. So we will talk about average velocity and average speed. So what is important for us is average velocity, average speed and average velocity. Okay, so these are important factors for us. Average velocity is represented something like this, V bar. Okay, so average speed, speed doesn't have any symbol, guys. So if you want, you can just consider this for average speed. Okay, so what is the formula for average speed? Average speed is nothing but total distance by total time. Okay, whereas average velocity is nothing but total displacement, very important, total displacement by total time. Okay, fine. So we don't consider uniform speed and uniform velocity. We always consider average speed and average velocity, and we have calculations relating to average speed and average velocity, right? So what is average speed? It is total distance by total time. Average velocity is total displacement by total time. Okay, and definitely since total distance is a scalar, so average speed is a scalar quantity. So this is also very important. Average speed is always scalar and average velocity is always a vector quantity. Okay, so this is all about the concept of average speed and average velocity. So now we will learn few examples how we can calculate this average speed and average velocity. See the first example, guys. Here there is an object which is moving with 4 meters per second. This is the speed. Okay, initially the object is moving with 4 meter per second speed for 2 seconds and it has come here. Okay, and after 2 seconds the object speed is 3 meter per second and it went to a final position, okay, in 5 seconds. Okay, so hope you can understand the question here. Say this is the speed of this object. Okay, it has moved here with this speed in this much time, and again from here the speed is changed. Here the speed is not 4 meter per second, the speed is 3 meter per second and it has moved to the final position in 5 seconds. Okay, so here you have to calculate, what you have to calculate? Calculate average speed and average velocity. Both you need to calculate. Okay. So what is the formula for average speed? First we will try to calculate average speed. So average speed is equal to total distance divided by total time, isn't it? Okay, so total time is here 2 seconds plus 5 seconds, right? So total time is how much? 2 plus 5, that is 7. And what about the total distance? What about the total distance? Calculate the distance here. So what is the distance here? We all know speed is equal to distance by time, isn't it? So speed into time will give you distance, right? So speed into time, speed is 4, time is 2. So 4 into 2, 4 2s are 8. So 8 meters is the distance. This distance is 8 meters. And what about this distance? 3 into 5. 3 5s are 15. So 15 meters is this distance. So what is this distance? It is 8 meters. What is this distance? It is 15 meters. So total distance is how much? 8 meters plus 15 meters. Right. So 8 plus 15, how much do you get? 23 by 7. Okay. Meter per second. So this much is your average speed. This much is your average speed. Okay. So hope you understood how to calculate average speed here. Similarly, if I asked you to calculate average velocity symbol is V bar. So what is the formula for average velocity? Displacement. Total displacement divided by total time. Okay, so this is your average velocity formula. So total displacement is how much? Object was here, finally it is here. So total distance is equal to total displacement here. Okay, so object is here, now it is here. So displacement is how much? 8 meters plus 15 meters only. So 23 meters. Divided by total time is how much? 2 seconds plus 5 seconds, that is 7 seconds. So here average velocity and average speed is same, isn't it? I told you speed can be similar to displacement. Okay, so average speed and average velocity is same. Okay, but now you observe this example. Okay, so here also you have to calculate average speed and average velocity. Both you need to calculate. Observe the question here. Initially the car is here and it is moving with the speed 10 meter per second for about 4 seconds. Okay, with this speed car is moving from here to here in this time. And again from here the speed has changed. 6 meter per second it is moving here for about 3 seconds. And again, it's moving backward direction. Its direction is changed. Okay, say with 2 meter per second speed, it is moving in this direction, right, for about 3 seconds. So you have to calculate, average speed. So what is the formula for average speed? We know it is total distance divided by total time, isn't it? So how much is the total distance? So distance, we know distance is equal to speed into time. Okay, so how much is this distance? Speed is 10, time is 4. So 10 4s are 40. So 40 meters is this distance. Okay, and then how much is this distance? This distance is 6 into 3, that is 18 meters. 18 meters is this distance. And how much is this distance? Total distance you have to do, right? 2 into 3. 2 3s are 6 meters. Right? So now we have calculated distance actually. Okay, so how did we calculate distance? The speed into time, that is the distance. Okay, fine. So total distance is how much? 40 meters, right? 40 meters plus 18 meters plus 6 meters. Okay, divided by total time. Time 4 seconds plus 3 seconds plus 3 seconds. Right? So this is how you will calculate. So you will get around 64 by 10, that's around 6.4 meter per second. Okay, so this is your average speed. And coming to average velocity, carefully you try to observe this diagram. Average velocity. See, what is this distance? 40 meters. What is this distance? Distance or displacement? Here distance is equal to displacement. Say instead of distance I can call it as displacement. So this displacement is 40 meters. This displacement is 18 meters, whereas this displacement is 6 meters, right? So what is our average velocity? It is total displacement divided by total time, isn't it? So how much is the total displacement? I can do 40 meters plus 18 meters. 40 plus 18 I can do, but minus, you see here, the car is moving again backwards, right? Say your final position of a car is somewhere here. So definitely you have to do 40 plus 18 you would have done, minus 6 meters. You must do minus 6 meters. Divided by total time is same. Right? That is 4 seconds plus 3 seconds plus 3 seconds. Okay. So how much is your answer? You will get 52 by 10. That's around 5.2 meter per second. So this is your average velocity. You observe the values of average speed and average velocity here. Average speed value is greater than average velocity. That means every time average speed is not similar to the average velocity. Okay, speed is actually it can be slightly greater than velocity. So this point is really very important. Average speed is always, it can either equal to or it can be greater than average velocity. Okay, so this point is very important. So every time it need not be similar with average speed. Okay, so average velocity can slightly be lesser than average speed, right? Say this is first example where you can observe average speed is equal to the average velocity, but here your average speed is not equal to the average velocity. Average speed was slightly higher, average velocity is lesser, right? Okay. And now coming to another example, observe this example. Quite an important example. Here also same thing, you have to calculate average speed as well as average velocity. Okay. So first let me calculate average speed. So average speed is total distance divided by total time. So first you calculate the distance. See, this is an object with 4 meter per second. With this particular speed it is moving in this way for about 2 seconds. Again from here with certain speed it is moving like this for about 3 seconds. So what is the distance here? Distance can also be calculated. You see here distance is always speed into time, right? So 4 into 2. So 4 2s are 8 meters is the distance. And here what is the distance? This much. What is the distance? 2 into 3. That is 6 meters is the distance. So average speed. Total distance is how much? 8 meters plus 6 meters. Divided by total time is how much? 2 seconds plus 3 seconds. Right? So this is how you will calculate average speed. Average speed calculation is much easier. But what about average velocity? Okay, calculation of average velocity you have to concentrate here. This is the initial position of an object and this is the final position of an object, and this much is your displacement, isn't it? This much is your displacement. So this displacement, so average velocity, how do you calculate? V bar is equal to total displacement divided by time, right? Okay, so time we know, time is what? 2 seconds plus 3 seconds, that is 5 seconds is your time. But what about the displacement? Displacement is this length, this much length is what your displacement. So how do you calculate displacement? You see here it's making an angle 90 degree, right? So it has become right angled triangle now. So you can apply Pythagoras theorem, right? So let me call this as S, displacement as S. So first I need to find out this S. So S square is equal to what is this displacement? What is this displacement? 8 meters. So 8 square plus 6 square, right? So what do I get? S square is equal to I would get around 100, right? So S is equal to square root of 100. So our S is equal to 10 meters. So your displacement is 10 meters here. Okay, so first we have calculated the displacement. It has become a right angle triangle now. So using Pythagoras theorem, we calculated the value of S. Okay, so S is 10 meters. Now substitute here. 10 meters divided by time, 2 plus 3, that is 5 meters. Right, so your average velocity is how much? It is 2 meter per second. 2 meter per seconds, right? So this is how you have to calculate if an object is moving in this particular way. Okay, fine. So anyway, this particular concept we will use it much later, and now we will see few numericals that have been asked in the previous board papers or in competitive examinations. Observe the first question, guys. Actually, from this question, we are deriving one formula. That formula can act as a shortcut to apply for many other questions. So let us try to get that particular formula. A person travels half the distance at speed v1 and rest half the distance with the speed v2. Find average speed. So always when a problem is given, try to draw the diagram so that you get more clarity about the question. Okay, so drawing a diagram is the most important. Once you can understand the diagram, half the problem is over. Remaining half is just apply the concept or select a suitable formula, substitute, calculate and give the answer. So drawing a diagram is very, very important here. So a person, say what is he doing? He's traveling half the distance with how much speed? With the speed v1. Okay, so this person is half the way. He has not completed his travel. He is half the way, and this half the way he has come with this particular speed, that is v1. And again from here he completed his journey. He reached his final point with a speed v2. You see, the speed is not same. With some speed, person traveled to half distance. Again he changed his speed, right? And remaining half the distance he has covered with the speed v2. So what is the total distance, guys? The total distance is d here. Total distance is d. And what is this much distance? Half the distance means what? D by 2. And what is this distance? It is also d by 2. Okay, so distance from here to here is d by 2. Distance from half the way to final point is d by 2. So what did they ask you to calculate? They asked you to calculate average speed, isn't it? So just stick on to a formula here. What is our average speed? It is total distance divided by total time. Okay, so total distance we know it is d by 2 plus d by 2, isn't it? D by 2 plus d by 2. Okay, fine. and divided by total time. So what is the time here? Say we all know speed is equal to distance by time, isn't it? So time is equal to distance divided by speed, right? Let me call the time required for a person to come from this point to this point is T1. Time required for a person to come from this point to this point is T2. So what is T1, guys? T1 is nothing but distance by speed. What is this distance? D by 2 divided by V1, right? And what is T2? D by 2 divided by V2. So time is what? T1 plus T2, right? So what is T1 and T2? Substitute. D by 2 plus D by 2 divided by T1 is how much? It is D by 2V1 plus D by 2V2. So, if you simplify this, we will get 2V1 V2 divided by V1 plus V2. So, our average speed is equal to, this is what we will get. 2V1 into V2 divided by V1 plus V2. So you just have to simplify this. Okay, so when you simplify, this is the final formula, or the final quantity you will get. Actually, this is important to remember. If you can remember this, similar problems can be solved very easily within a fraction of few seconds. Okay. I will show you with one example where we can apply this formula. So remember, say whenever they mention something like this in a question, see a person or an object travels half the distance with some speed and remaining half the distance with another speed. Say if this concept comes into a question, then you can always apply this formula. Say one example where we can apply this formula is this. You can observe this question. A car covers first half of the distance. See, there is a car and this car is covering first half of a distance with what speed? With 40 kilometer per hour. Okay. And remaining half the distance is covered with the speed 60 kilometers per hour. See? Half the distance is covered with one speed and remaining half the distance is covered by another speed. Speed is not same here. And you have to calculate average speed. So average speed in the sense, please don't take the average of these values. Don't ever do 40 plus 60 divided by 2. You will get 50. So 50 will be there as one of the option, where that is the wrong option. Okay. So average speed, always you have to apply a formula. Right? Okay. Say, how do you calculate? Average speed is equal to total distance by total time. Right? Okay. And now, you see here, how much is the total distance? See, say this distance, let it be x, and this distance, let it be x. Okay, so how much is the total distance? X plus x, x plus x. So you will get 2x. So 2x is your total distance. And coming to the time, total time is what? Let the time taken for a car to move from here to here with this speed, let it be t1. And here let the time be t2. Okay, and what is time here? Time, we know it is distance by speed, So what is the distance? X. X divided by speed is how much? 40. So what is T2 here? Distance by speed. So distance is X divided by speed is 60. So X by 60. So substitute, total time is how much? T1 plus T2, no? So what is T1? T1 is X by 40. And T2 is your X by 60. Okay. So when you do this, you can get your answer. But instead of doing all such, okay, you can simply apply this formula. See, I'm showing this problem in two methods. One is a direct method, normal method, okay, by applying a logic or concept. The other method is just this formula. Okay, see, they mentioned half the distance with one speed, remaining half the distance with another speed. Then what is the quick formula that you can use? 2 into V1 into V2 divided by V1 plus V2, right? So what is V1? You take one speed as V1 and this as V2, right? So what is V1? 40 into 60 divided by V1 plus V2, V1 40 plus 60. Okay, so just when you do this, you will get around 40 kilometers per hour as answer. Even when you substitute this, you will get 48 kilometers per hour as your answer. Okay, so this is one method and this is another method. Say here, just you have used the formula. So if you can remember this formula, it can help you to solve the questions in the easiest way. Or in case if you are bad at remembering formulas, you can just apply the concept or logic and you solve it. Okay, so in two methods, I have solved this problem. So answer is 48 kilometers per hour, right? And now we will go for two more questions. Coming to question number 3, which is one of the questions from previous NEET papers. A car moves a distance of 200 meters. Okay, so a car, right? And it from one place to it has come to another place, and the distance, total distance covered by this car is 200 meters, right? It has covered 200 meters. Fine. It covers the first half of the distance with a speed 40 kilometer per hour, and the second half of the distance with the speed V kilometer per hour. That V value we have to find out, guys. We need to find out that V value. Clear? Fine. And then the average speed they have given. Average speed they have given, that is how much? 48 kilometer per hour. Okay, so how do you do this? First half of a distance with this speed, second half of a distance we don't know, that's what we need to find, but average speed they have given. Can we use shortcut formula here? Say we have a formula, average speed is equal to V1 V2 to a V1 V2 by V1 plus V2, right? Say I will use this shortcut formula and I will finish off the question. Okay, but I can show you the elaborate method also. Just understand the logic here. Fine. So what is our average speed formula? Average speed. Okay, let me show it here. This is an elaborate method I'm showing you. Average speed is equal to total distance divided by total time. Total time. So total distance is how much? Total distance they have given 200 meters, but you see the units of speed, guys, they have given it in kilometer per hour, right? So this meters, convert it into kilometers, right? So I can take it as 0.2 kilometers, right? Say 200 meters in the sense 0.2 kilometers divided by total time. We don't know total time. Let the time for a car to move from this point to this point be T1, and from this point to this point the time taken by a car is T2. So what is T1? So we know time is equal to what? Distance by speed, right? So distance is how much? Distance will be 0.1 kilometer, half, make it half 0.1 kilometer and make it half 0.1 kilometer. Right, so time is 0.1 kilometer divided by 40 and T2 is 0.1 kilometer divided by V. So what you will substitute? Time is T1 plus T2, right? So what is T1? 0.1 kilometer divided by 40. What is T2? 0.1 kilometer divided by V. Right? So average speed value they have given, it is 48. So 48 is equal to 0.2 kilometers divided by 0.1 by 40, 0.1 by V. Okay, so just if you can solve it, you will get the value of V. Okay, so this is a normal method that you can go for based on the concept, based on applying concept or logic. Okay, but you see, if I apply a shortcut formula, just simple average speed is 48, right? 2 into, consider this as this speed as V1, this speed V2 we don't know, V2 we have to calculate. Okay, so 2 into how much? 40 into V2 we don't know, right? So divided by V1, V1 is 40 plus V2. Okay, say by this shortcut formula also you can calculate. This is much easier in calculation compared to this, right? See guys, you can calculate the answer and post the answer in the comments. Okay, so let me check who will post the answer first. That's all about, distance, displacement, average speed and average velocity, the most important concept of this chapter. And in my next class, I will come up with the next concept, that is acceleration and equations of acceleration. Thank you so much. Do subscribe our channel to learn the concepts in the easiest way and in a detailed way. See you in the next class.